Okay, so today we are going to solve 4 sum. This is a follow up for the question 3 sum and 2 sum, and this question has been asked in a lot of big tech companies like Amazon, Google, Meta, Microsoft, and you name it. This is a very important question and it strengthens the understanding of two pointer approach. Also, it explores the possibility of recursion. How does it do it? Basically, when we solve the question 4 sum, right, the interviewer will not expect you to solve it the way you solved 3 sum, maybe by using two pointers and keeping one pointer static and then moving this left and right and right. So this can also be done by that approach where you can have 4 pointers basically, but now you want to write a solution which is generalized, so that if the value of k, let's say k sum, k becomes 2 or 3, then your solution, whatever logic you have written, should be able to solve it. Okay, so going ahead with the question, the question is very similar, but the thing that has been changed now is there are now four elements that should be sum equal to target. Yeah, so given an array nums of integers n, return an array of all unique quadruplets, and there should the abcd should be distinct and it should be in any order, and yeah, basically the set should be a non-duplicate, it should be unique, right, all unique quadruplets. Okay, so if you see this example, you can say that the four number that are equal to 0 are this guys, right, then these guys, these guys and these guys, then these elements and these elements, right. And similarly, if we want to check what are the 4 elements, so first of all, if you check for the 4 element, it would be this 4 and then this 4, but the thing is, also it could be, I think, this 2 and this 2 also, but the thing is, the elements inside all these quadruplets are similar, right? So that's why the solution only has this list. This is a list of lists. Okay, so if you have solved the previous question, which is recommended to do solve those question at least 2 pointer to before this question, so the first intuition comes into the mind that time was, why can't we sort the array to identify duplicates easily, right? So that's what we are going to do for this question as well, right? So I'm taking an example, the first example itself, and the target is equal to 0. So what I'm going to do is, again, let's say that I set these two as a static and then I check all the number after sorting the array, then I'll be able to find the sets, right? And I can always check the current element, the current static element, with the previous one, and if it exists, then I can just simply move it, right? I can just simply move it. That's what we did for the left pointer there. Also you can do it for the right pointer, but doing it for the left pointer is enough, right? So this you can do, and this will give you the solution in O of n square, O of n cube time complexity as well. But this is not the interviewer is going to ask, right? Also the 4 pointer approach also, right? Why does it work? So for understanding how does it work, we'll go back to solve a simple math question. Let's say that we have 4 numbers a, b, c, d, and we want to say that if I sum this a plus b plus c plus d, it should be equal to a target. Then we can also say that b plus c plus d is equal to t minus a, also c plus d is equal to t minus a minus b, right? Yeah, so if this c plus d satisfies the two sum condition of t minus a minus b, then we can say that a plus b plus c plus d is also equal to target, and that's how you get the first list in your list of lists basically, right? So this is the trick. I just want you guys to read it again to understand, right? So we'll take any 4 numbers, we'll see if it is equal to target, then we'll take 3 numbers, we'll see if it is equal to t minus a, we'll see 2 numbers if it is equal to t minus a minus b. If it is equal to t minus a minus b indeed, then we'll pick up that list, we'll add the previous number to this list, and again add the previous number to this list. Okay, so from here only, if when I say that we will add the previous number to the list, you can see that I am going back on the stack. calls. You can see that I am going back on the stack calls. What do you think it means, right? It means recursion, correct? Recursion uses stacks, right? So we are going back a stack call, and we are keep on adding the previous number if the current call has satisfied the condition, right? I hope this makes sense. Please go through this part again and again, right, to understand, and don't go ahead before understanding this. Okay, so going back to the question, solving the question, like I said, we will need to sort it. So I have sorted this. So the sort, after sorting, it will be -2 -1 0 0 1 2. Ideally I'll need 4 pointers, so I'll put 2 pointers static, and these 2 pointer I'll move here and here. If I find any number which is equal to t minus this guy and this guy, then I'll add those two numbers, and when I go back I will add this number and this number as well, right? Then I will move this guy to here and then this guy to here, and then again check for two numbers, right? So that's how I am going to do it, but I am going to write a generalized approach for this. So the steps here is, we will sort it, we'll find the next k minus 1 sums until we find k is equal to 2, right? Because we already know how to solve it for k equal to 2. We are going to use recursion. Also there's a new term for you guys, I mean, I think some of you might know, but there's a term called as pruning. So what pruning means is, if a branch can never give a solution, then we will never check that branch anywhere, right? So here how we can use pruning is, if the first element, right, so let's say that the sum should be equal to target, right? So that means each value when divided by the target should be somewhere equal to the target, right? So if that value itself is too big, then it can't take, I mean, the first value itself, if it is too big, then the rest of the values will also be big. So that could not be a part of the solution. Right? So what we do is, we will not call anything and we'll just return, right? We'll not do anything else. So that's what pruning is. We will basically, if a base condition or if a logical condition says that a branch need not to be explored, then we will not explore it. That's what pruning is, right? So I'll go and try to explain the solution here. Yeah, so in order to solve it, we have created a k-sum method. This is a generalized method, right? I am passing the value of k as 4 first time, k-sum method, right? I have a list as a result. Yeah, I have a base condition that start is equal to nums dot length. If my thing has reached to the nums of length, then I'll just return the result. This is my base condition. Then the pruning condition, right? The pruning condition says that I'll divide target by k. I'll divide target by number of k's. If my first number itself is bigger than that, I don't have to go ahead and check all these other conditions. I can just return the result itself. Okay, now what I need to do is, if I have k is equal to 4, I need to find it for k equal to k minus 1, which is 3. K minus 1 is equal to 3. Then again I need to find it to k minus 2. For this condition, I already know that how we do it. So we have one variable static, we have left, we have right, and we move it from here to here. And if we see anything that is equal to the new target, which will be target minus nums of I minus nums of j, the previous things, right? This guy. So if it is equal, then we will just return it. So that's what we are going to do here. So we are going to start the loop from I equal to start to nums minus length. This is a duplicate check, that if the current number is not equal to, then only I want to do it, otherwise I don't want to do it, and I should be equal to start. Then this guy will return an array, right? Which this array will have the subset which will be equal to target. So I'll call k sum nums. I'll do target minus nums minus k. So first it will be, if k was 4, it would go from start to end, right? Start to end. So the new k would be 3, and the start would again be the next number, right? Okay, so the target will become this time, right? So first pointer, second pointer, again third pointer will go, and last pointer anyway will be nums of length, right? Which will go like this. And if two sum satisfies, what I want to do is whatever number that was here, right? I just wanted to add in the list. So that's what I'm doing. So I'm adding it in the list, and final result also I'm adding the subset, whatever subset I have received, right? Whatever subset I have received, the current previous number in the subset, I am adding it to the final list. Okay. So how k sum will be? Let's say, I mean, this already everyone should know, but it would be low minus high. Low is equal to start, which we are passing, and high will be the last element. We'll have the current sum. If the current sum is equal, we will add it. If the current sum is less, we will increment the low pointer, and the current sum is more, we will decrement the high pointer. Also the duplicate checks we need to do. So the duplicate check can be done by this, right? The duplicate check can be done by this, right? So this will give the solution. You just need to understand the trick here, that a plus b plus c, if you want it to be equal to the target, what we can do is c plus d is equal to target minus a minus b, and if this is equal to c plus d, then always a plus b plus c plus d is equal to target. So this is the main trick here. Pruning, if you do, you will find the solution. It's just that it will have a better time complexity if you do it pruning. Second thing is, you have to understand the two sum 2 problem, which was this, right? So then you can have a generalized solution if you have 5 sum, 6 sum, 10 sum, whatever, right? Always the time complexity of this would be n of k minus 1. So for 4 sum it would be n of q, right? Space complexity ideally should be O of n only, because you are not using any new spaces. So yeah, that's it for today. I hope you guys understood. Just go through the trick, right? The trick here says that if a plus b is equal to target c minus d, then a plus b plus c plus d is equal to the original target, right? And you can check for pruning to avoid the extra recursion call. Use maths like average and all, right? So we will try to solve more questions that require us to do pruning for optimization, and there also we'll note down the tricks, right? So that we'll form a good mindset where we can use pruning. Okay, see you in the next video. Thank you.